Hello. So, now we're going to cover something called the change of base formula. Wow. So, like, we might run into some, uh, weird values in our logarithms that are not necessarily easy to sort of work with. So, we can use the change of base formula to hopefully make the job a little bit easier on us. So, here's what this goes like. All right. And this is why the common logarithm is so important. So, log base b of a is equal to, here we go, log of a over log of b. Now, keep in mind, if I don't write log, it means we're really dealing with base 10. So the log base 10 of a over log base 10 of b is equal to log of b, log base b of a. So just keep that in mind, but we usually just write it like this. So this is a nice way of because it's real easy to work with base 10. It's really pretty easy. And we're about to see why. So, all right, evaluate each log using the change of base formula, and I guess let's bring up the calculator because I should show you the way to do it in the calculator. Choose base 10 because the calculator, there's an easy way to solve it for base 10. So, all right, this is equal to, if you just remember, right, log of a, so log is 64 over log of 16. Okay, so if we go to the calculator and just use log, it's just the button that says log. It's already in base 10, so we don't gotta worry about much. Log is 64 divided by log of 16. That's 1.5. Wow, very interesting. And let's kind of think about what's going on. So, log of 64 equals something. X. That is saying, all right, 10 to what power is 64? And using, if I just say log is 64, we get some weird stuff going on. And if I try to convert it to a fraction, we see that it's not really going too well. So, basically what's happening is we're getting these weird values for x now where we're not necessarily going to be able to find if your calculator can't convert it, it's probably an irrational number. So that is going to mean that all right, trouble for us, but luckily our calculators have base 10 just programmed right into them. So it makes it relatively easy to work with. Yada yada yada. All right, so next one. All right, log base 8 of 32. So we say log 32 over log of 8. Just it feels so lazy, but hey, it works. Log of 32 divided by log of 8. Get 1.66666 repeating, so 1.66 repeating. And it's really that simple. And it really helps us just find some nasty values. Log of 54 over log of 2. You can see where I'm like, my enthusiasm is gone, because when we reduce it to calculator work like this, it's just, I mean, if I, as a student, I appreciated it. All right, 5.7, blah, blah, blah. Because it was so easy, but as a teacher now, it's like, oh my gosh, like, get me out of here. So, then this one's log of 294 over log of 10. All right. So, just to show, log of 10, log base 10 of 10 is just 1. So what we are really just finding right now is literally just the log of 294. Because we're dividing it by 1. But even that alone is just a headache to deal with. I should have, you could have seen that. Oh, it's base 10, so you can just write it, whatever. So we're just doing log of 294, which is, some crazy decimal, 2.4683. Wow, real cool. I'm just gonna do 26. I think we get the point. Like, all right. So I got log of 1 over 36 over log of 6. Okay, so we have the log of 1 divided by 36 divided by the log of 6. I get -2. Ooh, that's kind of interesting. Well, I mean, looking at the problem, that's basically saying, all right, 6 to, some x power is 1 over 36. Well, 36 is 6 squared, and we know the fraction, is a negative exponent. So it might have been just easier to find without the change of base formula, but, it's still an option we have if you're being lazy, and maybe not even if you're being lazy, maybe your number sense just isn't quite like tuned enough to look at things like that and look and see those patterns. But hey, no judging here. So that is the change of base formula. Hopefully wasn't so bad.